Hello, Haripriya.
Hello.
In the last class, we have studied up to isothermal process. And few questions we have done. So these questions we have done already. So today, let's start with the new process, which is adiabatic process. Hmm. Now, what is an adiabatic process? See, what is an adiabatic process? Adiabatic process is a process in which heat exchange is zero. No heat exchange. Now, in this process, you will see if dq is equal to du plus dw is there, dq is 0. So du should be equal to minus delta w. Means delta w is equal to minus delta u. We know for every process the delta u remains same, which is minus ncv delta t. We'll use this information to actually derive the adiabatic process. I can write this as dw is equal to minus ncv dt. Now dw can be written as p dv minus ncv dt. Now what I will do, I'll make use of PV is equal to nRT. So P will become nRT by V. So I'll write here nRT by V dV is equal to minus N. Cp and Cv I've already derived now. If you want to get the value of Cv, divide the whole equation with Cv. It will become Cp by Cv minus 1 is equal to R by Cv. So Cv is equal to R by gamma minus 1. This only I am using. So NR I'll cancel. So dV by V is equal to minus 1 by gamma minus 1 dt by T. If I integrate on both sides, it will become log V is equal to minus 1 upon gamma minus 1 log T. So it will become log V is equal to 1 by 1 minus gamma log T. So I can write this relation as one minus gamma log V is equal to log T log of V power 1 minus gamma is equal to log T, which I can write as V power 1 EV power log T minus log V or 1 minus gamma is equal to constant. So I can write TV power 1 minus gamma is equal to constant. This is a relation for adiabatic process. Okay.
Yes, sir.
Now see, actually this we do not know. What we know is PV power gamma is something is equal to constant. How do we get it? Using PV is equal to nRT. This N and R are constant, so I can write P is equal to PV. Something constant. So PV into V power 1 minus gamma. No. Something mistake I'm doing. Acha, sorry. It's gamma minus 1. Now why I'm writing 1 minus gamma? It will become PV power gamma is equal to constant. This is the relation that student usually remember. PV power gamma is equal to constant. In an adiabatic process, see, this is actually the derivation that I have shown. How do we get this relation PV power gamma is equal to constant or TV power gamma minus 1 is equal to constant? Also, if you want a relation between P and T, that also you can get. How? What we want? P and P, na? I'll make use of this. P is equal to T by V. No, TV I do not. PT I want now. We are right. T by P. V is proportional to T by P, so this relation will become P. T by P whole power gamma is equal to constant. So P power 1 minus gamma, T power gamma is equal to constant. That's your third relation. These three relations, see, actually I don't recommend anyone to remember these three relations, all the three relations. Any one you can remember which is easier for you. You can remember the easier one. The most easier one for the students are PV power gamma is equal to constant. And once you know this, if you want relation between in the adiabatic process, if you want a relation between the 2 points which are undergoing adiabatic process, you can relate them by using either of them. Means PV power gamma is constant. Use PV is equal to nRT and then find out the relation between T and V if you want, or P and T if you want. Okay, remember any one of them. See, Diva, you joined late. Actually, what I was telling about the adiabatic process. Adiabatic process is a process in which no heat exchange takes place. no heat exchange take place between the system and surrounding. And now, if we use the first law of thermodynamics here, delta Q is 0, so delta U will be equal to minus delta W. And I already told in the previous classes that this delta U, that is internal energy, remains constant, remains same for every process. It's NCV delta T. So that what I did, dW is equal to PdV. I wrote P as a function of T and V because V and T are variable here in the integration of equation. So I wrote P in terms of T and V. PV is equal to nRT. Then I integrated and then I got this relation. Then again using PV is equal to nRT, I change this relation. That's how we get it. Okay, clear, Diva? Again, this Kanishka is left out today. No, she will say, sir, I did not understand. Now I'll tell you now what's the work done. How do we calculate the work done in this? Work done is PdV, which is P into V2 minus V1. Or if you want to do the work done, calculate the work done, you will have to again integrate the process. So why integrate again? Because we know delta W is equal to minus delta U, that's same, minus NCV delta TL, right? And this is minus NR by gamma minus 1 delta T. Now this can be written as minus NR into T2 minus T1 by gamma minus 1. So take NR inside, so it will become NR T1 minus NR T2. But because I know at every process PV is equal to nRT should be followed, so P1 V1 will be equal to nRT1 and P2 V2 is equal to nRT2. Now after this I'll be giving you questions, good questions. So I can write P1 V1 minus P2 V2 by gamma minus 1, and this is the work done in an adiabatic process. Which is the negative of the internal energy. Okay. Now let me give you some questions. Haripia, you understood now?
Yes, sir.
Okay, now try to do the questions. I'm giving. Attempt it. Are you getting idea how to solve it?
had minus 1156 joules.
Minus? No, they're saying it is 480 joule. See, just look how I'm solving. What about you, Diva? Are you getting any answer? See, let just watch how I'm solving it. The sample of Haribre, you just check your mistake where you have done mistake. A sample of gas with gamma is equal to 1.5 is taken to a adiabatic process. So that means the process is PV power 1.5 is equal to constant. Volume is compressed from 1200 to 300. If the initial pressure was means P1 was 200 kilopascal, or I'll write 200 to 10 power 3 Pascal. Initial volume was 1200 centimeter cube. Now P2 we want V2 is 300 centimeter cube. So PV is equal, P power gamma is constant. So I can write P1 V1 power 1.5 is equal to P2 V2 power 1.5. 200 into 1200 power 1.5 is equal to the pressure we want to 300 power 1.5. Now you will say, sir, why have you not changed the units? It's not needed because 1200 is in centimeter cube. This 300 centimeter cube, it will cancel. 3 4s are.
Sir, but it's in 200 kilopascals also.
But we'll get the pressure in the kilopascal only. P2 pressure will get in kilopascal only. (200 into 8 kilopascal). 1600 kilopascal is the pressure, final pressure, when the volume is compressed to 300 centimeter cube. Now the absolute value of the work done by the gas they are asking. Work done, we know it is what? P1 V what, P2 V2 or P1 V1? P1 V1 minus P2 V2 by gamma minus 1. So it is what is P2 V2? 1600 into 10 power 3 into 300 centimeter cube to meter cube. You will convert, how it will become? 10 power minus 6. Minus, what is P2 V2? Arey yaar, what I have done. Let me write it below. P1 V1, P1 is 200 into 10 power 3 kilopascal na. And Newton meters kar, okay. V1 is 1200 into 10 power minus 6 minus 1600 into 10 power 3 into 300 into 10 power minus 6 by 1 0.5 1.5 minus 1. 240 minus 480 by 0.5. It's 240 minus 240 into 2, it's 480 only. Minus 480 joule. See?
Gone on in calculation of ratios.
Wrong
I have converted it all into like main SI units.
Mhm.
And I don't know where I'm going.
See, when they're giving you the joule, means you have to, SI unit is okay, you have converted correctly. But kilopascal is there, you have to convert it into normal Pascal, Pascal Newton per meter square. Only centimeter cube, you have to convert it into meter cube, that's all. There only you have done some mistake. What about you, Diva? Understood? This conversion, you have to do it. P1 V1 power gamma is equal to P2 V2 power gamma. Using this process, you actually find out the volume at the unknown point. Let me give you some more questions so that you will become confident. Mhm. Actually, I want to give you one very good question that is being asked, that they actually ask. Piston based question. That's very common. I love giving piston based question, you know. Okay, just tell me, can you do this question? I think it is a bit difficult for you at this stage. See this question? Actually, nothing. You need not have to do anything here. It's not difficult. Just you have to understand the question first. No process, no adiabatic process, nothing. Just study and tell. Just read the question and then tell me whether you are able to get some, whether you are able to understand the question or not. And if you have understood, do you have any idea how to approach this kind of question, how to solve this kind of question? All the concepts that are needed, you already know. Don't worry. Hmm. Tell me, Haripriya or Diva, did you understand it? Do you want me to explain it?
So, like, from where should we start thinking in this type of question?
See, first let me explain you what is happening. An ideal, first you understand, generate approach, and I'll tell you how to solve it. An ideal monatomic gas is there. It's confined by a spring-loaded massless piston of cross-section this. This is a piston. This one is piston. Its area is given to us. Gas is initially at 300 Kelvin. Means its initial temperature T1 was 300 Kelvin. It's given to us. Initial volume is also given, V1. Now in this position, the spring was in relaxed state. Now the gas is heated by an electrical heater. They using it heating, it provided some heating until the piston moves out slowly without friction by 0.1 meter. Now the piston has moved out by 0.1 meter. Now the piston has reached to this position. Obviously the amount of gas has not changed, only the gas is now occupying the larger volume. Correct? And now if I tell you how much volume it has become now, initially the gas was at temperature at 300 Kelvin. Initially pressure was, it's given or not? Pressure is not given. V1 was there. 2.4 into 10 power minus 3 meter cube. Now after it's heated, the volume has become V2. which is V1 plus A into this X. 2 V1 plus, see the cross section, this, what will be the volume of this part by the distance it has expanded. A into X, na, the cross section area into the displacement X, right, Eva? Now what will be the pressure here? Pressure actually we do not know. Initial pressure also we do not know. And the one thing I can apply here. Initial pressure may be the atmospheric pressure. Because they have given now it's 8,000 Newton per meter. Atmospheric pressure is this. Means the gas was in the relaxed state, na, spring. So the pressure should be atmospheric pressure, P naught, 1 into 10 power 5 initially. Now the pressure, final pressure, how much it will become? Now the pressure, the spring has gone backwards. It's compressed. It's expanded because of the heat. Now the pressure should increase. Now the pressure should increase because of which the gas has expanded. What will be the pressure? P naught plus initial pressure plus there is an increase in the pressure which is caused by the spring force Kx acting in this direction. Kx force is there to the left, so Kx will force act this side because it's been expanded to the right. Kx force will act towards left, so the increase in pressure is P naught plus Kx by area, force per unit area. T2 they are asking, and we do not see, and in this case we do not know what kind of process is going on. We do not know, so we can, when we do not know what kind of process is going on, we can always apply P1 V1 by T1 is equal to P2 V2 by T2. Why? Because it's general gas law. The ideal gas is not changing its ideal nature. Means when a gas is not changing its ideal nature, at every point we can write PV is equal to nRT. Number of moles are not changing for a gas. R is always constant. Number of moles are not changing. Why? Because gas is not escaping outside or no gas is coming from outside to inside. So number of moles are constant. So I can easily write at every point in the process PV by T will be constant. So using this information, you can find the unknown temperature because everything is given to you, X, A, everything. Understood the approach? Usually in these kinds of questions, when the questions of this type are given, they usually give you, it's following some kind of process like adiabatic or isothermal or something. But if nothing is given, follow the ideal gas law.
Actually, they have told us that it's adiabatic indirectly.
Where?
The cylinder and piston are thermally insulated.
Cylinder piston are thermally insulated. That does not mean it's adiabatic.
What else could it be other than
See, if it is adiabatic, how come the gas is heated by the electrical heater? If the process is adiabatic, how can it happen that gas is heated by the electrical heater? When they're heating by some electrical heater, that means they're giving the heat from outside, na? From outside, heat is coming inside. So how can it be adiabatic process? Got it?
Yes.
Good thinking. This is how you should be thinking. Whether a process can be adiabatic or not, or isothermal or not. It cannot see. We can rule out every possibility. It's not adiabatic because it is being heated by electrical heater. It cannot be isobaric because pressure is changing. It cannot be isochoric because volume is changing. It cannot be isothermal because temperature is also changing, because they are asking the final temperature. So no process it's following. That's why I'm using P1 V1 by T1 is equal to P2 V2 by T2. Now solve. I have told you the approach. Now solve and get me the temperature. Take care of the units. See, I tell you, mainly in advance, actually they love giving these kinds of questions. Piston cylinder based questions, na? They like, especially in advance. Not earlier they used to give in mains also, but now they are not giving because mains physics has become very easy. It's very scoring. So from now only, because you are in 11th, because now from now only I'm telling you, probably in your next year also the physics will be easy. So the most scoring part will be physics and chemistry. So your physics should not be weak. Chemistry, anyway, I know it won't be weak for you. Physics should not be weak. Because why I'm saying physics should not be weak, because physics is a logical subject. Usually the students who do not understand, they're not able to do anything. Achha, now, na, you solve only A part. B part I'll tell you later, because it will become difficult for you to comprehend it now at this level, because it would require its advanced level question then. Half kx square was p1 delta v that you have to do. What happened? Are you able to solve, or should I let me solve it? You're taking too much time. One into 10 power 5, 2.4 into 10 power minus 3 divided by 300. 1 into 10 power 5 plus 8 into 10 power 3 into what is x? 0.1. 10 power minus 1 divided with what is area? Is it given? 8 into 10 power minus 3. Wow. What is V2? Will be 2.4 into 10 power minus 3 plus 8 into 10 power minus 3 into 10 power minus 1. Means 0.8 plus 2.4, 3.2. Actually, I'm getting a feel that this kind of question has been actually asked in advance. (2.4 into 10 power 5 into 10 power minus 3 by 300. 2, 5. 2 into 3.2 into 10 power 5 into 10 power minus 3 divided by T2. (800 Kelvin). I'm getting 800 Kelvin temperature. Don't attempt this part, second part. Later I'll do it. Later I'll tell you, because at this stage it will become difficult. Even you have to apply dq is equal to du plus dw, but applying that will become difficult. Because du will be ncv delta t, dw will be p1 delta v plus half kx square. Because initially when the pressure was this p1, because of increase in volume, the work is done by this pressure as p1 into delta v. Now the work which is done on the spring is stored as the potential energy. So the work done by the spring will be half into k into x square. Total work will be this. Using that, you'll have to find out the delta Q. Haripriya, is it difficult? This part was easy only. Second part is a bit difficult for you, but let me show you how I'm solving it. Later you can just check it, how it will be. The delta Q, the heat supplied, will be delta U plus delta W. Delta U will be NCV delta T. So delta W will be P1 delta V plus half kx square. So just put the values and get the answer. I will get N P1 V1 by R T1. TV is, it is a monatomic gas, I think. 3R by 2. 800 minus 300 Kelvin plus initial pressure was 1 into 10 power 5 volume difference is area, which was 3 or some 8 into 10 power minus 3 into 10 power minus 1 plus half into 8,000 into 10 power minus 2. This value you have to calculate. RR will cancel 10 power 5 into 2.4 into 10 power minus 3. With 300 Kelvin. 500. 80. 40. I don't know anyone is following or not, because I am only solving. One 120 into 5. 600. 120. 720. 720 joule of heat is provided. That's the B part. I don't know you are following or not, but I'm giving you this question as a homework for you. Because I think at this time you must have slept. But this kind of question was given in advance sometimes. And this I have solved in my YouTube channel also. Someone gave me this doubt. Lesson, I think, some student. Okay, let's end the class now.